Hi everyone, I'm David Byrne and I'm doing my PhD at Oxford University on noble gas isotope tracers. When we think about noble gases in the Earth's crust, we normally think about them as coming from three primary sources. Fortunately for us, they're all relatively well understood, and we can then measure them to a high accuracy in groundwaters or petroleum phases such as natural gas, and then try and deconvolve how those isotopes got there and what that's telling us about the movement and age of water and gas in the Earth's crust. So to start off with, we have this equilibration with groundwater at the surface, an influx of groundwater into aquifer systems, which brings in atmospheric isotopes. And because noble gases follow Henry's law to a high degree of accuracy, they're pretty much as close to an ideal gas as you're ever likely to get. We know this composition relatively well. Anyone who's done work in volcanic systems might be aware of the use of helium-3 as a tracer of volcanic activity. We actually see it pretty much everywhere we look to some extent. In extensional basins, there's always likely to be faults where mantle fluids, trace amounts of mantle fluids are able to come along. And so we are able to deconvolve any mantle-sourced gases into the Earth's crust. And finally, we have the production of certain isotopes of noble gases by radioactive decay, uranium and thorium primarily producing helium-4 by production of alpha particles, but also smaller amounts of production such as potassium-40 decay into argon-40. And that's really crucial because it tells us about the age of certain fluids in the subsurface. And they're released from the mineral grains into the surrounding groundwater as a function of temperature. So the project I'm specifically presenting today is a little study we did in South Texas looking at an unconventional hydrocarbon system, the Eagleford Shale. What's cool about this system is that it has a large regional dip towards the southeast, and we were able to take samples from lots of producing gas wells across that transect. We measure all the data, we measure all 23 noble gas isotopes in each sample. We come up with some sort of conceptual models about how the gas and the water is interacting in the subsurface. We formulate some equations to try and explain those, and then we try and fit these equations to our data points here. So if you want to hear any more about that, come visit me on my poster. Thank you very much.